I'll say,
It's okay. We'll see. We'll see how it goes. You
Okay,
got it? So
it's
I got it.
recording now. You're good to
okay.
go.
Hi, everyone. Thanks for coming back. This is going to be the third one that we're doing. What we're doing is we're going through 10 pages at a time of papers that I wrote on Paul Laviolette's work on subquantum kinetics, anti-gravity, free energy. I wrote these papers in the spring of 2018, and it wasn't until 2021 when I released them. And I did get a hold of Paul, and he did read this. He saw these papers, which is kind of cool too. I don't know if everyone knows that. So last time we were talking about, I think we were talking about bootstrapping at the end, and how when T.T. Brown took AC and put it on top of DC, that's when everything went dark. Kind of the end of the 50s, sort of 58, 59. By 1960, anything to do with electrogravitics was absolutely classified. In fact, it's more classified. Sam would know this. It's more classified than even nuclear secrets, as a matter of fact. As is lightning. That's something that I'll talk about later, because I know the lady at NASA who specializes in lightning. So yeah, let's get going. Brandon, do you want to try and read? So we're
Yep.
going to start at page 11 here, and
Okay.
we'll just jump in and start going.
Okay. So this is Eddie's notes on subquantum kinetics, page 11.
Yeah.
It is the only unified field theory to predict the existence of electrogravitic coupling at low potential energies. High voltage DC applied to a
wing shaped.
wing shaped structure subjected to a supersonic flow that what's that one
That results in
that results in a significant air drag reduction on the structure and the virtual elimination of
friction
caused aerodynamic heating. In the late 1970s, Russian scientists at the Lof Institute in St. Petersburg, led by Anatoly Glimov, carried out an interesting experiment that demonstrated how plasmas could reduce air drag.
So I'll just stop you there for a second, Brandon, because I want to talk about be around the B2, which is B2 bomber, which is what we're going to talk about today. That's what Paul talks about in Secrets of Anti-Gravity Propulsion. Around it, we have something called a vacuum plasma bubble sheath. And that is actually what they're talking about here when they said that plasma could reduce air drag. You know, they did an experiment, but actually how it functions is it's called a vacuum plasma bubble sheath. And that's from the Pius patents and from Stevati Aerospace and David Wilcock. So I'll let you carry on there. I just wanted to add that in.
That demonstrated how plasmas could reduce air drag. With a positively charged exhaust stream, the B2 would function essentially as an electrogravitic aircraft. Ceramic dielectrics are a likely choice for the B2. Ceramic dielectrics also have the ability to store large amounts of high voltage charge.
Yep.
Brown noted that he obtained a greater electrogravitic thrust when the positive electrode was curved and made much
much larger
than its negative electrode.
So that is something that we did show in the last, there was a little drawing that I had, and Amber asked the question, so what is it a wave that gets set up? And I said, yes, it is. It's actually a soliton, which is a standing wave. And it all has to do with the distance in proportion to where the negative and the positive is, how the soliton gets set up. So, okay, I'll let you carry on with the next page,
And this
Brendan.
is the right page. Yep.
It
Okay.
should say the B2. Yep.
Yep. B2 leading. Okay. The B2 leading edges are segmented by 10 centimeter wide struts. Quite possibly these struts electrically isolate the sections so that they may be individually electrified. In this way, through proper uh, control
Control. Yep.
of the applied voltage, it would be possible to gravitically steer the craft. Brown had suggested a similar idea as a way to steering his saucer craft.
Okay, I'll stop you there for a quick second too, because we're going to start talking about Hughes Aerospace, and I just want to say this: at the end of the 50s and starting into the 60s, it was the Kennedy family, it was the Trump family, because actually Donald Trump's uncle, John Trump, was the guy that went into Nikola Tesla's safe and got all the secrets out. But what I found out quite recently, because one of Al's buddies bought the serial number 001 of the Hughes 500 helicopter, which was Howard Hughes's personal helicopter. So what I found out is that Hughes Aerospace had a huge part in all of this as well. So it wasn't just the Kennedy family and the Trump family, it was Howard Hughes himself. And now we're going to talk about the radar system. Hughes Aerospace, nobody really knows what they do exactly, but the radar system that is used in the B2 was built by Hughes Aerospace. So we're just going to talk about it now. Just wanted to add that. So you can carry on, Brandon.
The Hughes radar units may also be supplying microwave energy to the B2's leading edge to assist the air ionization
Yeah, yeah,
process. Microwave frequencies emitting along the leading edge would
readily.
readily ionize
I,
the
yeah,
approaching air and allow the B2's high voltage electric field to discharge a great flux of positive ions.
yeah.
High voltage radio frequency field might work just as well. That's this one.
Yeah. So they're using the radar system to essentially put frequencies out there. So they're going to talk a little bit more about it here.
Okay, the high voltage generator could just as well run on cold intake air with fuel combustion entirely shut off. As Brown pointed out in his electrokinetic generator patent, it is to be understood that the other fluid stream source might be substituted for the combustion chamber and fuel supply.
Yeah. So any sort of fluid, right? So it's not just now this next section is really interesting because there's a switch on the dash of all these planes that says coast mode. And I happen to know a few of the active members still that fly some of these planes, let's just say. And that switch has been confirmed in a roundabout way. So just to let you guys know. This next section is wild. And if you notice on the left-hand side, I wrote in the column, wow, and then free energy and circled it. So this port is really important. So I'll let you keep going there, Brandon.
Okay, in such a coasting mode in which jet combustion is entirely shut off, the B2 would be able to fly for an indefinitely long period of time with essentially zero fuel consumption, powering at self
Itself, yeah,
powering itself primarily with energy trapped from
tap,
its sorry
tap.
tapped from its self-generated gravity gradient.
So there it is. When I did this theory of anti-gravity with Stavati Aerospace, it was all Paul's words that I put on there, but there was one sentence where I said, I think the key to anti-gravity is a gravity gradient. So there it is right there. And this is all Paul's writing, you guys, right?
Yep.
So yeah.
For example, during coasting, the kinetic energy of the scooped airstream would arise entirely of the scooped airstream would arise entirely from the craft's own forward motion, with
Yeah.
this motion being due to the pull of the electrogravitic propulsion field. The kinetic energy of this ionized airstream is responsible for linearly accelerating negative ions down the B2's exhaust. What's that
Ducts,
word? Ducts,
exhaust ducts, yeah.
exhaust ducts, and hence for creating the
Multi-megavolt.
multi-megavolt potential difference relative to the positively charged engine body. The craft's high voltage electron collector grids, the overwing exhaust ducts, and other collector surfaces, possibly hidden in the exhaust nozzle, recover a portion of the electric power to run the ionizers for the craft's flame jet generator. Provided that this power drain is not excessive and the plane's propulsive gravity field can be adequately maintained, the craft would be able to achieve a state of perpetual propulsion. Whoa.
So I said, wow, because this is really important. So this state of perpetual propulsion means that craft or the B2 or whatever it is nosing down and falling into that well that's in front of the ship. And then there's a hill from behind also pushing it. So, but when we talk about perpetual propulsion, that's exactly what I was talking about with the first video that we did, the first 10 pages, where if you apply high voltage to the high K material, you can get it to spin indefinitely. So free energy is actually really, really easy. They just didn't want you to know how it works. So I'll let you carry on.
As stated in chapter 1 of Paul's book, Eddie.
Yeah, this would be,
The
this stuff is
anti-gravity,
all from Secrets of Anti-Gravity Propulsion, right? It's all from there. Yeah.
as stated in chapter 1 of the Paul's anti-gravity book, such perpetual motion behavior is possible in devices having the capability to manipulate their own gravity field.
Yeah.
Brown noted that his electrogravitic propulsion system could run just as well using compressed gas source, such as carbon dioxide, as the ion carrying medium, as it could using the exhaust from a jet engine. It is possible that the B2's superimposes an AC signal on its DC bias potential.
Yeah, I'll stop you there for a second again. This is what I just talked about at the beginning of this. This is called bootstrapping, where we have a DC bias voltage, potential voltage, and then we put AC on top of it. It's called bootstrapping. We do it in when we build vacuum triode amplifiers, for example. That's what we do. This is a very, very powerful thing. And again, this is when everything went black, when Brown showed the military what this was capable of. So I'll just let you carry on again, Brandon.
Right. So it is possible that the B2 superimposes an AC signal. I read that bit. Okay, I'll read it again. It is possible that the B2 superimposes an AC signal on its DC bias potential. The Aviation Studies Electrogravitic Systems report mentions using high K dielectrics energized with 50,000 kilovolt amp of power as a means for propelling a supersonic combat vehicle of the sort proposed in Project Winterhaven. I'll just mention a little bit about the 50,000 kilovolts.
Mm-hmm.
You could be using low power. You could be using like 40 watts, like a light bulb. It's 40 watts or 60 watts. You're just pumping up with a transformer. You're making the current very, very small and the voltage very, very high.
Yeah.
Anyway.
Yeah. Exactly.
This clearly implicates the use of high voltage AC. So we might venture that in addition to the DC bias potential, a high frequency AC field is applied between the wing leading edge and exhaust ports.
Exhaust ports.
Exhaust ports. Okay. If the excitation frequency was chosen to be 30 megahertz, that there
a quarter wavelength.
If the excitation frequency was chosen to be 30 megahertz, then a quarter wavelength would have fit across the 10-meter distance from the exhaust ducts to the wing leading edge. This would have allowed the applied AC field to resonantly build up to a high volt potential, similar to what Brown was achieving with his electrokinetic apparatus. This could be done with a high voltage Class C amplifier designed to automatically lock in on the wing's resonant frequency. By repeatedly charging and discharging the craft's dielectric, the AC field would also have kept the craft's dielectric from fully polarizing and building up an electric dipole moment that might cancel out most of the field propulsion thrust effects. If 380 of these asymmetric capacitors were distributed.
Okay, I'll just stop you for a second there. Again, asymmetrical capacitors are the key. You can buy them. They're very low powered and they're called gun diodes. So GUNN diodes. For anybody out there that knows electronics. We could actually try using something like that in an experiment, actually, is something that I have thought about in the past. But I'll let you carry on.
If the 380 of these asymmetric capacitors were distributed over the B2's lower wing surface, they would collectively produce an upward thrust of 152 tons, sufficient to lift a fully loaded B2. Dielectrics are known to exist and have K values more than 4 times higher than the K value of baryon titanate. Adding in the power requirements for the AC microwave source used to excite the creative electrode.
A
What was that
negative,
say?
negative electron.
Negative electrode. Well, it could be creative anyway. I'll call it negative. I'm just joking. The negative electrode, the total power consumption might
Might become
become
or might come to about might come to about
100 watts per thruster or 30 kilowatts for
total 38 kilowatts total. So 38 kilowatts is actually not that much power when you consider that's what it takes to fly the B2. It's really not that much power.
What's that word? At forge. What's this word here?
That is LaForge. I think LaForge, it's a person.
La Forge.
Yeah, I think it is LaForge
Yeah,
because
La
it's named
Forge
after
field,
like a scientist or a mathematician. I forget which one, but yeah, that's a name, LaForge.
yep, yep.
La Forge field propulsion thrusters. And I think it's at Forge field. Anyway, field propulsion thrusters. A capacitor measuring 38
38. Yep.
centimeters high, 8 centimeters wide, and 1 meter long. Made with a K equals 4,000 barium titanate dielectric, would be capable of delivering a lift of 2 tons when charged to 100 kilovolts. Power from generators would be fed to a network of high voltage step-up transformers attached to each thruster.
So they're using transformers essentially to step the voltage up, which is something that can be done. It's something that we do in tube amplifiers, for sure.
Okay. Dr. Bogdanov gravity impulse beam generator pulses would propagate at superluminal speed, 64 times the speed of light. The gravity impulse beam is observed to produce repulsive longitudinally directed gravitational forces, hence in line with the direction of wave propagation. This is just as Tesla had observed for his shock discharges. It also confirms a key prediction of subquantum kinetics that electrons would produce matter-repelling gravity potential hills, G Etheron hills, and that a change in the electric or gravity potential field would propagate forward as a longitudinal potential wave.
Yep, it's very important. Paul's genius. let's just say it.
Subquantum kinetics offers the following explanation of how these gravity waves might be generated. A shock discharge from a cathode to the anode would produce a wave having a sharp rise in electric potential, followed by
electric field potential.
Electric field potential, followed by a more gradual relaxation. Subquantum kinetics predicts that an electron should generate a gravity potential hill. An electron discharge then would be accompanied by an
In phase.
in phase gravity potential wave. Another important factor must be involved. Another important factor must be involved virtual
Virtual
charge.
charge. Yeah, very important, ultra
The
important.
advancing electron discharge would be accompanied by a negative electric potential wave. And not only would the front of this wave have a very steep drop in voltage with distance, but also its voltage would change with distance in a highly nonlinear manner. So this
Shock front.
This shock front would be associated with the creation of a very high negative virtual charge density that would produce an enormous matter-repelling gravity field. Oblensky's magnifying transmitter is energized by the discharge of Mark's capacitor bank. The electron shock discharge is conducted down length of a horizontal oil filled tube called a Teslatron, which contains which contains a lengthwise coil that helps to sharpen the shock front.
Yeah, so this is really important. A Teslatron is an actual device, a tube. Nikola Tesla in 1939 retired as the vice president of worldwide engineering with RCA. And RCA at the time was the leader in all vacuum tube technology in the whole world. In fact, it was the highest degree of technology that they had at the time, right? And it was all to do with Tesla. So the Teslatron is really important, guys. Okay, sorry, I'll let you carry on, Brendan.
Okay,
Coulomb, I think.
What's that one again?
I think it's Coulomb waves exert.
Coulomb waves exerts primarily longitudinal forces on charges. It
encounters.
So Coulomb wave exerts primarily longitudinal forces on charges it encounters, rather than the transverse
forces.
The negative swing in electric potential at the forefront of the Coulomb wave would carry a forward-moving negative virtual charge density. Yep. The subquantum kinetics electrogravitics coupling relation predicts that this would induce a gravity wave having a rising G field and a positive gravity potential gradient. This would exert a longitudinal repulsive force on masses if transversed. The positive
swing.
The positive swing in electric potential that immediately followed it would carry a forward moving positive virtual charge density that would induce a decreasing, that's the last page,
decreasing G field
and an attractive force on masses if it encountered.
Yep.
It's the field, as the field continued to oscillate from negative to positive, the induced gravitational force would change. Was that what?
Yep, change, yep, yep, change.
between repulsion and attraction. Since the individual cycles in this wave
Train, wave train.
this wave train are sawtooth shaped with differing rising and falling slopes, they should produce a net longitudinal gravitational force that presumably is repulsive. Scientists working for the military have known since the early bomb tests in the late 1940s that the electromagnetic pulse shock wavefront what's that one?
From a nuclear explosion.
No, this word here, but wave front. Is that wave? Wave. Sorry, it's the 1940s that the electromagnetic pulse shock wave from a nuclear explosion propagates outward at superluminal velocities when measured near the explosion's epicenter.
Yep.
Subquantum kinetics attributes this breaking of the light barrier to the creation of a tremendous radial ether wind generated by the electric gradient of the advancing shock.
Yeah. So that's the 10 pages that we're going to do today. Do you guys have questions? You guys want to bring up anything as we went along? You could have asked questions as we went too, but
I think it's just a question. When we play the video a few times, it should make more sense what I've said.
Yeah, and this, you guys, these are all Paul's words. Like, I literally took his words. I just found all of the good stuff and put it all in the right places is kind of what I did. And I did this over the course of 2 nights. I can remember it because I actually had this cabin built, and the cabin was brand new, and I was up in the loft, and I didn't have a rail yet because I was sleeping up there, and I was always worried about rolling off and falling down 8 feet. I just remember it tremendously that's when I did it. But thank you, Brandon, and everyone for being here with the third part of this. There are going to be 8 of them in total. So we're getting close to halfway through this, and this is fantastic. So yeah, is there any comments or anything before we stop the recording?
I was just wondering how simple it is. Sorry, you go ahead, Amber. You go.
I think it's interesting that they figured it out when they were working with the nuclear bombs when they first started working on them. It's interesting that they figured that out, especially the part where the shockwave is going faster than the speed of light. Yeah, it's exactly. Interesting that they figured that out, and
but
of course they didn't say anything. They kept it secret.
Yeah, remember when I said that the most secret things were the Manhattan Project, the nuclear stuff. But what is actually more secret than that, the most secret thing on the planet is actually what we're talking about right now.
Yeah.
Essentially, right? So Paul knew this in his brilliance, figured it out and figured out how it related to subquantum kinetics. So that's why we're all here to honor him, because that's exactly what we're doing, right? And it is such an honor to have Brandon and Sam and you and everyone, Legia and everyone involved, and Mariana. Mariana was so happy that the girls are involved too. So that's fantastic. So maybe we'll stop the recording here, and next time it'll be part 4, and we'll do another 10 pages next week. So we're actually getting through this really fast, which is awesome. And it's amazing that it's all